All right, so let's take a look at the specifics of the one-way ANOVA test. We'll go through kind of this phantoms process again. So the purpose of this test is to perform a hypothesis test to compare K population means. So the first population mean would be mu1, then we'd have mu2 for the second one, all the way up to mu k. So your parameter statement, if you're writing that down and not just marking that skip to the end, is I will test the claim that these populations have equal means. And so you just fill in whatever that is. So for example, we're looking at that electricity distribution problem a little bit ago. So I will test the claim that the average electricity use is the same across all those populations. Your null hypothesis is that all those means are equal. So mu1 is equal to mu2 is equal to mu3 all the way out to mu k. Your alternative hypothesis is that not all of the means are equal, meaning at least two of them are different. Okay, our assumptions and conditions that we mentioned earlier. So simple random sample and independent. And then the normal, we said it doesn't have to be super normal. It just needs to not look like it's really wonky. And then the equal standard deviations, that's the one where we had a little formula we could use because really they're probably not super equal. But what we said was that if you took the largest standard deviation out of those populations and divided it by the smallest of the standard deviations, and if that number was less than 2, then we said that it was okay to check this off. Okay. With all of that in place, what we're doing is a one-way ANOVA test. And there's our test statistic. We will be using technology to help us get that. So there is a way to get the test statistic from Excel without doing all of that work. And that's by going to the data analysis and using ANOVA single factor. So it's actually the very first item on the list. If for some reason you had your test statistic and all you needed was your p-value, there is an f.dist.rt that you can use. And you put the value of your test statistic in there. And then your 2 degrees of freedom. So that first degrees of freedom is k minus 1. And then the second degrees of freedom is that n minus k. So this is your number of populations minus 1. And this is your total overall sample size minus your number of populations. Okay, and then as always, if p is less than alpha, we reject our null hypothesis, meaning that not all of the means are equal. If p was bigger than or equal to alpha, we do not reject, meaning we don't have evidence that those means are anything other than equal. And then our conclusion with the p-value of blank at the blank % significance level, we either do or do not have sufficient evidence to conclude a difference exists in the means of, and then you would add your context there. All right, so let's actually go through that entire electricity problem from start to finish and see how this test works out. So join me in the next video.